And we are live
Ta-da.
from Tartu. Hello, everyone. Yeah, we're in Estonia, the second largest city, is it, in Estonia?
Yes, it is.
Tartu. And yeah, we actually had a GG session on Android just a moment ago in the office. We're in the Zero Turnaround office right now, and Oleg and another guy called Mattis run the Google Developer Group Android. So we just had a session there, and we're straight into the virtual jug now. And
I'm pretty good. I like to host you here in Tartu. This is where I spend most of my time, and it's absolutely lovely.
It's awesome to be here, and it's lovely weather. It's mildly better than the UK right now, although the UK is actually fairly warm right now.
Nah, the UK's pretty good, guys. I'll say over here.
And so joining us today, as you can hear, is Mr. Daniel Bryant. Daniel, how are you?
Hey, good guys. Thanks. Good.
And you're in London today, I take it.
Guildford, actually, just outside London.
Yeah, quite close. Awesome. So, Daniel, so what do you do, Daniel?
So I've just changed, actually. So I was a consultant at a company called OpenCredo, awesome people in London, actually. So I'm doing more freelance work now and actually working with a spin-out of OpenCredo, because OpenCredo is probably a service company. We're working with a spin-out who's looking at products around microservices and microservice testing. So stay tuned. You'll notice on the slides I'll present in a minute, there's a bit of branding. Specto Labs, I hope a few of the viewers have seen Hoverfly, our sort of premier open source tool for microservice testing, and that's kind of where I'm focusing my efforts at the moment.
You say you were a consultant, did you say, at OpenCredo?
Yes, well, I think my grand title was Chief Scientist.
I was going to say, because you're not a consultant, Daniel, you are a Star Trek character, weren't you? Chief Scientist.
Yeah, totally. Yeah, I didn't do much science, and I won the chief.
So Daniel, you've been working with microservices for quite a long time, right? And you also do, don't you do a newsletter?
Yes, I've just handed that one over, Simon, actually. So I ran the Move Services Weekly for, about a year and a half now, but I've handed it over to a colleague of mine, or ex-colleague of mine at OpenCredo, Steve Judd. So shout out to Steve, he's doing a great job. I think he's put several out already, but I'll be sort of looking in every so often, seeing what they're up to. But they're sharing the latest and sort of greatest news in the microservice world. So yeah, hat tip to Steve for doing a great job there.
Oh, okay, so that's interesting. I didn't realise that was an OpenCredo thing. So people can join that newsletter then as well.
Yeah.
And so your current company is kind of training based.
So Specto Labs is it's mainly product company. So we're looking to develop sort of some commercial stuff around a bunch of open source tools. I know it's quite challenging to monetize open source, but we've got some great people in the team, some great ideas around. A bunch of us have been working on microservices for many years. So between us all, we're hoping to monetize some of the open source products we're sort of working on by doing by providing, say, data management and all the enterprise kind of stuff on top. We are doing a bunch of training actually as well, because we definitely realize a lot of our clients are a lot of potential clients of the products are kind of struggling with microservice testing. It genuinely isn't easy, and I've got some of the scars there as well. So we're doing a bit of training to kind of get people started. We've got a couple of conferences actually, so shameless plug, I'll be at Go to Amsterdam in June with my colleague Andrew Morgan doing some training. We're doing some stuff, I think the Skills Matter coming up, so stay tuned if you're interested in that kind of thing. If you're in London, in Amsterdam, I think we're also doing one in Copenhagen soon. I'll be doing that kind of stuff as well. So if you want to learn more, today's not so much on microservices, but if you do want to learn more about microservices, I'd love to see you at one of those events.
Awesome, great tips. And so before we get started, I'm just going to flick over to my screen. Hopefully you can see my screen. I believe you can.
Yes.
Excellent. So this is what we have up next. Continuous delivery with Java and Docker, the good, the bad, and the ugly with Daniel Bryant. You can follow Daniel on Twitter at Daniel Bryant UK, all one word. And Daniel speaks wonderful tips and amazing things that you'll never have thought. So do check out Daniel there. The video is sponsored by Zero Turnaround and Rebel Labs. And whoops, I was on the wrong slide. There we go. If you want to hear more about Zero Turnaround, you're welcome to go to their website. They actually have 4 products, or we actually have 4 products: JRebel, XRebel, JRebel for Android, and also XRebel Hub. So do check some of those products out. And you can also have free free trials of all of those at zeroturnaround.com. On today's session, you're welcome to join us on IRC, #virtualjug. If you have any questions, ping us there, and we can rudely interrupt Daniel, whatever sentence he's going through, and we'll rudely ask him the question. If it's not exactly relevant to what we're talking about, I'll probably leave it till the end, so not to damage Daniel's flow too much. Please do share the group in session. We're almost 11,000 members now, I think, on Virtual Jug. And if you have any feedback at all, you can, if it's about the session, please do ping Daniel on Twitter or in IRC. Any feedback about the Virtual Jug at Virtual Jug or at SJ Maple. So without further ado, Daniel, let's get going. I'll pass control back over to you. There we go.
I'll fire up my screen. So let me know, gents, if it looks good. How's that looking?
Yeah, I can see your slides.
Super. So I'll just launch straight in, I think. So yeah, welcome everyone. Thanks for coming along. I always enjoy the VJug sessions. They're a great community. And as Simon said, 11,000 members. That's just like, that's crazy good, isn't it? Crazy good. So yeah, we're going to be looking at continuous delivery with Java and Docker, or more rightly, Java and containers. I've just done the most with Docker of late. So the kind of expectation with containers is pretty high, I find. In a lot of my consulting work I've done over the last, yeah, like Simon said, 5 or so years, I guess now. Containers have been around, 3 or 4 or whatever. The expectations with containers are super high. Yeah, everything kind of looks great as this picture shows, and people are, going to just carve up their architecture, chuck it in a container, good to go. But the reality I found is, unless you've kind of really thought about, say, some architectural implications, definitely some operational implications, and continuous delivery being a strong one, really struggle. And particularly if you've got a kind of tire fire going on around your architecture or your operations, what you actually end up with is a tire fire in a container. Yeah, that's definitely what I found from a couple of clients. And I've done it, I've kind of got a bit stuck on some of these things as well in the past. You'll notice, the containers here on fire, the little people in the corner there, like I'll point them out there. This is generally what we refer to as DevOps. Yeah, constant kind of firefighting when we haven't got stuff kind of in check. So today we're going to be looking at some of the sort of mistakes I've made, like perhaps that's some of the bad, some of the good that my team and I have kind of worked on, and some of the stuff I've seen from the community as well. And we're going to relate this to very much continuous delivery in the Java and Docker space. Now, continuous delivery is a massive topic. So today I'm not going to be live coding anything. It's going to be more sort of focusing on the processes and the tooling, kind of higher level stuff, and the good, the bad, the ugly. But I've got a mini book out on O'Reilly, so it's 50 pages or so, with an associated GitHub repo as well. So if you want to know more of the technical details, I've got like a Vagrant image there, a few Java apps, a Spring Boot app, a Drop Wizard app, for example, that I've kind of containerized and put in a very simple shop, which I'll talk about a little bit more later. But the actual code and stuff's there, so you can go in and dive, fork the repo in GitHub, have a play around. Got a hat tip to Nginx, because Nginx sponsored the book, so you can go along to the bit.ly link at the bottom, grab the book. It's all free online. You do have to give your email address, but once you give your email address, it's all free. If you see me at a conference, you might well get a hard copy of the book. So check out my sort of conference schedule on Twitter, and I'm happy to give out free copies of the book as well. Got to do a hat tip actually to Container Solutions, Adrian and Kevin from Nginx. They did a very nice webinar about a few months ago now, actually, called Building a CD Pipeline, which looks in a lot more depth than I've done with actually using, say, Jenkins pipelines to build workflows for Java and other languages into Docker. So they've covered that stuff quite nicely as well. So we're going to be focusing, at the higher level, I guess. And the kind of the TLDR, as I like to say, the summary stuff, is that now you're going to be packaging your Java apps in containers. A container image should become the build pipeline single binary. And don't worry if that doesn't make too much sense yet, because we'll look at what a build pipeline is, and we'll look at what the sort of single binary is as well. But it's really important to package your thing once, push it down a pipeline, test it, do some quality assertion and QA, that kind of stuff, and then deploy that unit of code, that image. Second thing I found is adding metadata to container images is vital. Same thing when probably many of you used to deploying, say, Java wars or jars, and you might be using, say, Nexus Sonatype, or Sonatype Nexus, or you might be using JFrog's Artifactory. We typically apply metadata to our artifacts, and that's essential with containers, though it's a little bit more challenging, I've found, and it's still not perfect, but I'll give you some sort of hints of what I've discovered on that. Actually already put, I saw on the meetup asking about some of the Java and Docker issues they may have seen. So there is some changes required to the way we run the JVM in a containerized environment, and therefore a strong thing I've learned is we must validate the sort of constraints imposed by containers on Java, and as a lot of people like to say, the kind of non-functional requirements. Yeah, so the scalability and performance and all that kind of thing. We must validate that in the pipeline. And I think in order, once we've done that, the step back almost, or maybe even the foundation for it, is to cultivate what I've called a mechanical sympathy. And all that mechanical sympathy means, and I've stolen it wholeheartedly from Martin Thompson and Dave Farley, and that basically means you have some kind of sympathy, some kind of understanding of the platform you're deploying onto. So containers in this space, but it could be cloud, it could be PaaS, whatever. Mechanical sympathy is kind of understanding one level down from where you're working on. So if you're a developer, you need to understand a bit of the operational fabric. And I've got burnt a couple of times by deploying onto container runtimes and not fully understanding what was going on there when I first started. So that's the kind of high level thing. Simon's already done a great intro, so I won't labor on this one too much, but this is me. Love getting involved in technology, love getting involved with the team aspect as well. Always on Twitter, so do feel free to tweet at me now, and I'll grab some, I say some tweets at the end or whatever if anyone's got any particular questions.
Quick question, actually, Daniel. Just in that little intro there, you said you saw some problems. What were the? So Mukake is saying, what problems have you seen?
Like with the, so I think I mentioned about the JVM. Simon, is that what you're picking up on?
I think it may have been. Let me just ping Mukake.
Yeah, because I've got a whole slide in that one in the end, actually, because that was kind of the the executive summary, should we say? Because there's a bunch of challenges around the way the JVM sees the host in terms of CPU and memory and these things. But it's probably better if I wait till, if you don't mind, wait till the slide later on, because I've got more notes there. I'm bound to get it wrong if I'm not careful.
Okay, no worries.
Is that all right?
Yeah, that's fine.
Sweet. So continuous delivery, let it sort of winding back a second and running through. I'm sure many of us watching sort of know what continuous delivery is, but just as a reminder, in case you don't, because it is super valuable, it was kind of popularized by Jez Humble and Dave Farley's book in early 2000s, I think it was, and it's about producing software in short cycles and getting basically feedback and learning so that the software is valuable and it's robust, in that it's secure and kind of stands the test of your users basically hammering it and so forth. And one of the first principles of the Agile Manifesto is continuous delivery of value to customers. So that all fits in nicely here: Agile, Lean, continuous delivery, DevOps as well, which we'll look at a bit later on. One thing I would say with continuous delivery, some people I work with get super scared, particularly management types sometimes, when you mention about continuous deployment. Now, I'm going to say continuous delivery is not continuous deployment. Continuous deployment basically implies that you, as a developer, we push some code and it ends up in production straight away. Totally viable. Many companies do it. Companies I work with don't do it. So you can do continuous delivery in that your software is always ready to be deployed, but you can still have a human in the loop saying yes or no. If your company demands that, or if you or your managers or leadership team really want that, don't worry. Continuous delivery is a great process. You don't have to continually deploy stuff unless you want to. So I hope that this is not controversial, but I think the creation of what we call a build pipeline is mandatory for continuous delivery. I think Jez's and Dave's book basically really hammer this home. And if you haven't seen a build pipeline, again, this is what they typically look like. Very quickly run through from left to right. This is a kind of process, basically the code that you write, the journey it takes before it gets into production. If we look on the left here, you can see we're coding on our machines. We then, when we're happy, we say push to GitHub or Bitbucket, or take your pick, some kind of version control system. And then typically we build the code using, say, Jenkins or Circle CI, Travis, take your pick. And then we might do some code quality analysis, so some Sonar cubes, some find bugs, all that good stuff. If we're happy, say there, with some unit tests, some integration tests, perhaps Surefire, failsafe in the Maven world, and we're happy with the code quality, we then push our jar, our war, into an artifact repository. We then, maybe we even use Jenkins, or we use something like Rundeck. We orchestrate a deployment to QA. We might do some acceptance testing, some performance testing, maybe get some humans in the mix to kind of poke and prod stuff. And then if we're happy in QA, it gets moved on to staging. more of a like production environment, a like live environment, and you might have closer integration with third parties in staging. You might be, say, mocking stuff. Good old Hoverfly. I'll shout out to Hoverfly there, my the open source tool I work on with a great team at Specto Labs. But when you get to staging, you might be using something like a sandbox environment or even the real system to make sure what you're testing is as like live as possible. And then if you're happy at staging, you push on to prod, and then, the continuous delivery does not end at production. You should be monitoring, you should be logging, actively, say, perhaps running what we call synthetic transactions, kind of test transactions, test user journeys, if you like, to make sure stuff we're pushing up isn't breaking things. So continuous delivery definitely includes that feedback loop, yeah? So we must make sure really good observability, really good monitoring, really good logging. And there's many good frameworks and libraries I can recommend. I think I've mentioned a few later in the talk as well. The very typical Java continuous delivery pipeline. I worked on this since pretty much like early 2000s. I remember when Hudson and Jenkins and these kind of things. It does change a bit now with the impact of containers. Yeah, containers do change that pipeline a bit. Just winding sort of back again a step. I'm sure many of us know what sort of containers are, but I'm sure many of us haven't been lucky enough to use things like Docker yet. So just a quick recap. Container technology is essentially OS level virtualization. Now, many of us are used to, in the Java world, are used to app level virtualization. The JVM itself is a virtual machine, yeah, so app level virtualization. And many of us, again, are used to things like VMware, vSphere, Cloud, Zen. If you're on Amazon, you're on Google. Many of us are used to hardware level virtualization. So OS level virtualization fits in the middle between those things. Fits sort of above the hardware, but below the app VMs, or just if you're running a native binary or whatever. Popularized, obviously, by Docker, and they've done an amazing job. Hat tip to Docker. They've wrapped some awesome APIs around things. They've really popularized, the kind of container thing. Containers have actually been around for a long time. LXC, jails, Solaris zones, they've been around for years, actually in the Linux kernel. But Docker, I think, have driven the most sort of change of late. Hat tip to CoreOS Rocket. RKT is a really cool alternative to Docker as well. There's LXD, which is Ubuntu, Canonical's Ubuntu on the right there. And Microsoft are really stepping up their game with containers as well. Though, to be fair, I haven't worked too much with the Microsoft side. But it fundamentally, a lot of us are treating containers now as a way to package and execute software. Most of my experience comes from Docker, so we're going to be talking about Docker the most today. The container image, you've got your Java jar or your war. You're now putting that into an image which does contain an operating system, which we'll look at in a second. But not only now is your jar or your war your single sort of thing, your single deployable unit, actually it gets wrapped with a container image. So the container image therefore becomes what's called the single binary, the single thing we push down the pipeline. We really must avoid rebuilding things after we've tested. So say if we push to staging and we're happy, then we suddenly rebuild the thing we're going to deploy into production. That's that's kind of scope for stuff to creep in that we haven't tested there. So just as we should always deploy, the jar we're testing with containers, we should always deploy the single container we build at the start of the pipeline. That's what should end up in production. Now, obviously, loading the config in there is a bit different, and we'll look at that later on. But yeah, the container image should be the single binary, a sort of key message there. This is the pipeline we just looked at with the sort of typical Java pipeline. If we add, say, Docker, or containers, but I'm going to look at Docker. If we add Docker in the mix, this is what I think it looks like, and what I've experienced. I've worked in a bunch of projects, and we pushed through to production just as a kind of to share some of my experience. Worked with Not on the High Street, awesome company that does kind of marketplace, a bit like eBay and Etsy. But do check out notonthehighstreet.com if you're looking for gifts. They're awesome. But I did a bunch of work with them. They've been really cool about talking about it. Nick Jackson and I have shared other videos online which you can catch. So my experience there was running Docker on Mesos on Amazon. I've done some Kubernetes work as well, a little bit of Docker Swarm stuff, and even flirted a little bit with Amazon ECS. But my main experience was Mesos and Kubernetes. But taking Docker as our kind of our main container technology, it alters, in the dev machine, you probably want to containerize stuff now. Even if you don't work with containers, you want to test on your local machine with containers before you push along, the code to the pipeline. That's number one on the diagram. Number two, you're no longer pushing just a jar or a war into, say, Nexus or Artifactory. You can certainly still do that, but you need to push into a container registry as well. You build your Docker image in this case, you push it to something like DockerHub or CoreSQL key, that kind of thing. So that's that definitely sort of alters the flow of the artifacts. We spin up things and test them is a bit different because Docker is in the mix now. We're no longer, say, spinning up a jar or deploying something onto Wildfly or Tomcat or whatever. We're probably going to run fat jars within Docker, or maybe even Tomcat within Docker. But 3 means we're going to have to alter the way we run our tests. And 4, kind of fundamental, that now what we're running on in QA, in staging and production is going to be a bit different. It's no longer maybe, CentOS kind of with Tomcat on top, and then we deploy our war. Now it's going to be probably something like Kubernetes or Mesos or those kind of things, Amazon ECS and Docker Swarm, take your pick. You can even run, say, Docker natively. Actually, Google and GCP announced them earlier this week, I think. You can run Docker containers natively, and you can run them with systemd and so forth. But I'd strongly recommend you use something like an orchestration framework because it just gets rid of a bunch of headaches in terms of managing containers. So number 4, the fabric you're deploying onto will now change. So let's look at creating a pipeline for containers. That's kind of the diagram we just looked at. Let's go through systematically from left to right and have a look at sort of some of the stuff, some of the mistakes I've made, perhaps some of the good things I've learned, and a bunch of other stuff I've seen with various clients I've worked with as well. So we'll just we'll jump off in number 1 in the dev machine. So one of the key things, and I think it's regardless of containers and all this kind of stuff, and even not Java, it's completely agnostic of language. We should strive to make our dev environments as like production as possible. So if you are going to push code down the pipeline, you now need to locally test the code running in a container, because that's ultimately how it's gonna run. We need to make sure we use base images from production. I'll explain a little bit on the next slide what base images are, but think of them as your kind of core OS, CentOS, Ubuntu, Debian, these kind of things. I've seen a bunch of people say deploy on CentOS in a container in production, but be testing and building on Ubuntu images locally. And in theory, Linux is Linux, but different distros definitely do differ. Yeah, so CentOS, some of the security stuff's a bit different, say, than Ubuntu, and there's different subtleties with package managers and things. So whatever you're using in production, CentOS, Ubuntu, whatever, that should be what you're using in your containers locally and throughout the QA process as well. Just on this note on the bottom bit here, it says must be able to build test containers locally. I'm a strong believer of this in terms of you should be able to perform some happy path tests on your local machine, and ideally all tests in your pipeline, your unit tests, your integration tests, even your kind of bigger scale test traps driven via a UI should ideally be runnable locally. I know it's not always possible because some of those tests are super resource intensive. You're running Selenium and stuff, but often I'll try and sort of parallelize those things, say, in production. But you should be able to run everything locally, because if you need to debug it, if something's going wrong in your pipeline, if you can't jump onto the box or you can't run your debug tools, shout out to good old Zero Turnaround there. If you can't run these kind of things locally, it's often really challenging. Yeah, so make sure all your tests and so forth can be runnable locally and with containers in this case. Big lessons I learned early on was around the Dockerfile content. It is super, super important. And Dockerfile, it's kind of like a manifest file. It specifies the base OS. So you can see in the example at the top, OpenJDK. You add in your artifact is the line 2. We've got a fat jar here, for example. We expose some ports. We're running on 8010 here, and then we set a command to run, in this case, Java. I'll explain the urandom thing later, but fundamentally, we're just running a jar, java-jar, app jar. But this, particularly if developers aren't, say, operationally aware, this is a big jump for a lot of developers. Suddenly, they're getting closer to the operational, closer to the kind of the metal, if you like, and it can be really big in terms of OS choice, operating system choice. Massively impacts performance and security and a bunch of other things. Your company might have a policy they only run Red Hat Linux, for example. That's kind of one to watch. How you inject configuration, how you add the build artifacts, the ports you expose and stuff. This stuff for a lot of developers, and myself definitely, when I came into containers a few years ago, it's quite a jump if we're not used to doing operations stuff. And then there's also things like if you're running, say, Java, do you run in a container? Do you run the JDK? Do you run the Java runtime only? Do you run Oracle? Do you run OpenJDK? These kind of things. So it can be a lot to learn if you're kind of used to this stuff. If you're used to just shipping jars and wars, this is a big jump. Just a few things I put in quite recently around this thing. You'll notice in my line 1 where I've got from OpenJDK, that's actually an OpenJDK base. I believe it's Debian under the hood, or maybe you can do Alpine as well, I think. I've actually noticed I've not done best practice, and I'll flag a couple of points in the talk where I haven't done what I've said you should do. So do what I say, basically, not what I do, is the key thing. And if you look, there's a bunch of tags that are available. This screenshot I've just flicked up is from DockerHub. It's a publicly available repo. You can actually specify even the Java release version, so 8U121 and these kind of things. I'd strongly recommend doing that than what I've actually done in the example here, which is just the 8-JRE is the latest Java 8 JRE, which might change when they do security patches and all these kind of things. So the more specific a version you can specify, the better it is, because the more repeatable it will be. If you specify 121, you're always going to get 121. Whereas what I've done on the demo, as things get upgraded, subtle changes could break your application. Yeah, so just one to watch. In terms of the OpenJDK and Oracle JDK, I'm actually a big fan of OpenJDK, done some sort of work promoting that in the past, a massive fan of the work that OpenJDK do, and ultimately Oracle, IBM, Red Hat, and so forth, they all consume from the OpenJDK anyway. The OpenJDK is the base sort of open source part of the Java development kit. But Oracle obviously are very popular. A lot of people run the Oracle JDK or JRE in production, and Oracle very kindly have now got a GitHub repo where you can download Docker files for the actual Oracle JDK from 7 and 8, I think. You can also, there is actually a container registry, if you can see there, and a hat tip to Bruno Borges here for telling me about this. There's actually a container-registry.oracle.com where you need to sign up to some stuff there, but you can download pre-built Docker images of the latest JDK, Oracle JDK there. So if you have to run Oracle JDK, it's totally possible. For a while, there were some slight contentious legal issues around could you expose the JDK in an image publicly and stuff. There is some legal things around there, so if that's an issue for you, definitely look into it a bit more. Oracle have got some documentation on that, but OpenJDK sort of top right of the slide, Oracle JDK on the left. Make your pick. One of the key things I want to mention on sort of in relation to all of this slide, and it's the notion of talk to your sysadmin people, talk to your operations team. If you've got them, it may just be you. But I found operational knowledge of the sysadmin team and the ops team is super valuable. They know, we only run JREs in production. We must run Oracle JRE because of these reasons. We only run CentOS. So I've really increased my collaboration with teams I've worked on. Primarily, I think I identify as a developer, but I've done a whole bunch more ops stuff over the last, say, 3 years, 4 years. But I've learned so much. I owe so much to many sysadmins I've worked with who are happy to share their knowledge with me. And so I think we need, when we come to things like creating a Dockerfile, which does have operational knowledge in it, we need to make sure we chat to these people. Yeah, so, develop. It's the whole DevOps thing, yeah? Now we're all kind of responsible and we should share knowledge. I appreciate this isn't always easy, but we should really, I think, as developers, strive as much as we can to chat to the sysadmins. So, yeah, next thing I see in terms of this, is one of the perhaps the bad ones, is difference between prod and test containers. And when I say prod and test, it can also be production, say, and development containers. Some people want to create two images effectively, a sort of local development one with, say, a JDK in and full OS, bunch of test tools, and then they want to have a production container, a stripped down container. Now, I'd strongly advise against this if possible. It can be tricky and there is nuance to this, but I've seen application and configuration drift. So one team I worked with had kind of test containers and test containers and production containers, and subtle things, tweaks to the test container didn't get included in the production container. And ultimately what we were deploying wasn't the same as we were testing against. It's that whole notion again of, the single binary. There's a bunch of ways sort of to work around it. I really like using test sidecar containers. So I build my production container, and then I might have other containers, kind of like we call it a sidecar, a container that sits alongside the production container. And the container sidecar contains all my testing tools. Yeah. So when I'm doing my tests, I spin up both containers, and the testing one might drive the testing, or it might contain, say, sort of MySQL database with some these kind of things. So this graphic on the right comes from Alexei. He's got a very interesting proposal actually around adding an on-test command to the Dockerfile, which I think is very interesting. So I'd like to see a bit more discussion around that one possibly. I think sometimes the test workflow hasn't been fully worked into the Docker vision. Docker are amazing at spinning up stuff locally, and they're really good at deploying stuff into production. Docker are investing a lot of money in this kind of stuff, and people like Google and stuff are spinning up Kubernetes. But the middle bit, the testing, which I think is pretty much like one of the most important points or important sort of things in the pipeline, has not been given as much love as it perhaps deserves. So Alexei's blog, he talks a lot about how we can sort of perhaps add these on test things, make testing more of a first-class citizen within the Docker or the container workflow. So that nicely covers number one, sort of running stuff locally, and now we're going to have a look at the number two. It's kind of creating the container, sort of putting it into registry, these kind of things. So in fairness, I won't go into this too much because the report covers it in more detail, and it's kind of boring if I just start running through it, I think, on the slides. But fundamentally, when I'm doing a Java project, when my team is doing a Java project, we just build as usual. I'm a massive fan of, say, Jenkins, and we just build using Maven, Surefire, and then we typically use CloudBees Docker build and publish plugin. So CloudBees are the commercial side to Jenkins. They're really awesome people. They've released a bunch of plugins for Jenkins that help make building Docker images really quite easy. So I like doing this, and you specify a few extra config settings in your Jenkins. You have to put your key in for publishing to DockerHub, for example. But ultimately, build your jar, wrap your jar with a Docker file, or more correctly, I should say, put the jar or the war in the Docker image, which typically is done for a Docker file, and then you push the image to the registry. And I'm a big fan of DockerHub. If you're doing, you can get a private account, it's all good. I've run a few local, or teams I've worked on, I've run a few local registries. Sometimes companies insist you have to have a registry behind the firewall, which is totally cool. So we've done that. A couple of years ago, it was a bit scary running stuff locally because of various upgrades that were going on. But these days, I think that running registries locally is totally valid as well. But again, the book goes into more of that detail. So we'll kind of skip over that a little bit, and then more of the talky stuff today, I think, is probably more interesting. So one of the lessons team and I, not on High Street, actually learned was that metadata is really valuable. Sort of adding data to your images, because they are the main things going down the pipelines. So I'm talking about things like, maybe you're using kind of semver, like the Maven Gav coordinates, 1.2.1, that kind of thing. If you're doing a lot of sort of changes, you might be putting the git char in as your kind of application version. But whatever you sort of want to put in there, it basically should allow you to track back when you've deployed something, what version of the code exactly was deployed. Particularly, I've seen with the same microservices and with containers, people can deploy a lot more rapidly. So it's very important to make sure we know what we're deploying. Yeah, in the monolith, you deployed once every 2 weeks or once every month or whatever. It was pretty obvious it was that version of the code. Whereas when you start mixing up microservices and containers, you can push it out a lot quicker. But we need to know what we've pushed out. Things like build metadata, super important. Date, image name, vendor, etc. I like the idea, and this is where I've struggled, or this is where teams I've worked on, we've kind of struggled with quality metadata. I like adding sort of a QA stamp on the image I've tested, saying it's been security audited, these kind of things. Docker, in fairness to them, Docker Inc. are doing some really cool work around cryptographic signings in this space. I don't think it's open source is the only snag. So the Docker sort of the commercial workflow allows you to run a bunch of tests and then cryptographically sign the image, and you can only deploy that image to production when it's got, say, 3 signatures that prove it's been QA'd, prove it's been audited, etc. But in the kind of open source space, it's a little bit more challenging. And Gareth, in particular, Gareth Rushgrove, I've got to mention here, and you can Google for these slide decks. He's done a lot of thinking around this stuff. So if metadata is important to you, and I hope you think it is, please do have a look at Gareth's presentations he's done at DockerCon. Before we look into a bit more of the metadata stuff, one thing I would say is beware of the latest Docker tag. So latest is a bit of a misunderstood tag, I think, and it simply means the last build tag that ran without a specified tag or version specified. So I've seen a bunch of stuff even when I've been developing locally, but definitely in a CI environment where when we weren't tagging stuff, and we had a mixture of not tagging and tagging, it got super confusing as to what was the actual latest version. And this blog post on the right I've mentioned just goes into much more detail than I've done here. Totally worth reading. It is a strong argument, basically. Every time you build a container, do version it. You can see along the bottom there, I've got Daniel Bryant UK, which is my DockerHub ID/test, semver at the end as the tag, 2.4.1.
And Daniel, quick question in from Kay again. Where do you save this metadata on the container after it's been pushed?
These are great questions, and that comes in the next slide, actually. Yeah, perfect. So I'll move on to that one. Next slide. One thing I was going to say is you'll notice in a few of my examples, just a hands up on this one, I have not tagged my containers properly. Someone pointed this out at a talk the other day, and I was like, oh, no. So please ignore my examples in terms of the lack of tagging. Always tag and don't use latest is the key thing. So as Simon, and great question there from the audience, in terms of, I like using labels. So labels, you can use things like there's a maintainer command within the Dockerfile. So you could do maintainer, Daniel Bryant, and you can also add more data in there or whatever. And that one's being deprecated now. Labels have been in for a while, so you can add labels to your image, and it's kind of just key value stuff. So I think I've got a good example here from the microscaling systems people. So hat tip to Ross Fairbanks here. It's a great example I've borrowed. I know Ross quite well and the microscaling people. So in answer to the question, you can see on the bottom of this image, we've got labels. I like doing the kind of reverse DNS type thing to make sure the labels are unique, because otherwise you might get clashes if you just put vendor or URL or whatever. And you basically add in the data you think is important. So here we've got the vendor, the kind of company name, the URL, the description, etc., etc. Want to do some clever things at build time, so you might want to sort of inject the properties into the labels at build time, and perfectly. We're going to hat tip to the microscaling people, to Liz, to Anne, to Ross, and the others. They've got a make file, and I'm not sure how many people are cool with make files. It's a bit old school perhaps, but I genuinely do like make files. I think they're very useful, kind of just like a way to automate a bunch of stuff, particularly around builds. And they've got a make file, which I've linked there, which allows you to automate the generation of label metadata, such as git char and build time and stuff. So you can use that to push in as you're doing a Docker build and Docker push. You can use these things. DockerHub allows you to do it as well. You put a file in the hook/build directory when you're building or doing a Docker build, and DockerHub will automatically run a script with a few caveats in there, but you can use that to inject metadata via DockerHub if you're building there as well. So the good people from Label Schema and Microbadger, which is backed by microscaling solutions or microscaling systems, they've done a lot more thinking around this stuff than I have. So I definitely defer to them. If you want to know a bit more about labeling and some they've come up with a schema for labels, which I think is very interesting, and they've got some badges, hence the Microbadger. So check out their stuff if you want to know more about sort of labeling up your containers, adding metadata. All at build time, I will say. Runtime, you can add labels. So you can do, in my example at the top, Docker run in daemon mode or background mode, -- label. You can put your label in. I put in, say, the load balancer name as front door Nginx here. It's a bit limited. It's ephemeral. As soon as that container stops, that label is gone. So you can query it while it's running, like via various CLI commands or via the Docker API. You can Docker commit, so you can do Docker commit on the running container, but that will create a new image layer. So it kind of violates my principle, or the principle I've taken, of a single binary. So this is a bit of a limitation at the moment, to be honest. It's not yet possible to update a running container. There is a proposal in flight on the Docker GitHub repo. I put the issue number down the bottom. So if you're interested in trying to encourage Docker to allow us to update running containers with labels, strongly advise you to do a +1, using the emojis on GitHub. But I think it's a really useful idea, not only for adding, say, QA kind of metadata, but a lot of us who are using, say, like traffic and other kind of reverse proxies, we want to be able to label containers at runtime so we can direct traffic to them. So there's a bunch of use cases. Docker don't seem to be super interested in it for various reasons, I'm sure good reasons, but I would like the ability to add labels at runtime. At the moment, I kind of I rely typically on the registry I'm deploying to. So say it's JFrog, Artifactory, or Sonatype Nexus. They both support Docker images as well as jars and wars now. They allow you to add metadata via their system. So you're not adding metadata onto the container or the image, but you're adding data via Nexus or via Artifactory. So that's the solution we've done up until this
So there's
point.
consensus in IRC that this is maybe a little bit too late. So McKay says Dockerfile labels is too late. You build, push, then run tests. But after your tests pass, is it at that point we should be tagging rather than later?
No, it's a great question, Simon. Yeah, it is true. So I mean, definitely you can do the pre-build stuff in terms of metadata around like who's building it, what time, and the Git SHA. That stuff can totally go in at build time. But I think the point's well made. Yeah, many of us in the Java world are used to annotating, say, our jars and our wars. Exactly as you mentioned, once we've done all our QA, the only way around this, bar Docker adding support for this or other containers adding support for the updating labels, the only way to do it is to use something like JFrog's Artifactory or Sonatype Nexus, some kind of repository, registry that supports adding metadata. So you can put it in the build pipeline, you can build stuff, and then you can basically call out via the API to Artifactory and say, update this image's metadata in Artifactory to now say it's past QA. And then when you deploy, you do a check. You call the Artifactory API, and you say, has this container passed QA? If yes, then deploy. Does that make sense?
That's perfect. Thank you.
And it's not perfect. I'll hands up on that one. So yeah, let's move on to number 3. I think we're bad for time here, actually. In the book, I talk about some component testing, and I've got like a really simple shopfront kind of shop application, and it's really simple. Like my UI skills are pretty minimal. Hands up on that one. So it's super simple Spring Boot app with a bit of time leaf, and I've got like a Drop Wizard product catalog and another Spring Boot stock manager, kind of microservicey, but it's not really microservices. But just as an example kind of app that we then can Dockerize and kind of test. Now, the tests I'm going to talk about now, I'm going to use a bit of Docker Compose and so forth. They're not truly real world examples because it's really tricky to put some of them into a book and a bunch of other things. If you were running this kind of thing in production, you typically have an API gateway, I would imagine, something like Nginx, Kong, Apogee, take your pick. You're obviously going to have databases associated with each service here, and that's something I haven't talked about in the book because it's a whole new world in terms of, well, not a whole new world, but a whole different world, testing with data. So I'm happy to kind of talk about that later, perhaps, or I think it's worth probably some other blog posts. It's a common question I get asked. But I'm going to look at this example of kind of how do we just spin up one of our services, one of our components, and test with Docker now. So I'm going to kind of ignore the API gateway, kind of ignore the database. Don't get me wrong, I know it's super important, but there's only so much you can cover, I think, in one presentation. I'm a massive fan of using Jenkins still. I know it's kind of popular at the moment to use Circle CI, Travis, Drone, all these other good things. They are really cool. I love them as well. I'm still a fan of Jenkins. And I think with Jenkins too, they've done some really cool stuff as well. And the pipelines, it used to be called workflows. I think, the way now you can basically codify your deployment and that codification of it, as you can see in the diagram here, the node, the stage, and these kind of things, you can put this code in your version control. So not only have you got your Java code, but you've got your Docker file, you now have your Jenkins file as well, which I think is a really nice idea to kind of localize all the code. So the examples I'm going to run through use the kind of pipeline stuff, and I like the nice sort of display of if you're building stuff, doing tests, you can make this pipeline arbitrarily complex. I usually keep it fairly simple, but I think the Jenkins way of displaying it's quite nice. If you try their new Jenkins Blue Ocean UI, it looks even cooler. I haven't got the screenshot on this example, but yeah, Jenkins I think does the job for me. I'm quite a Jenkins fan. So in terms of testing individual containers, I use the CloudBees stuff yet again. So if we're using Jenkins pipelines stuff, we can literally say, in this code example, we're spinning up on a node. We maybe can specify some criteria for that node, the Jenkins node. Very simple stage in this one, and it's literally using the CloudBees plugin stuff to do, docker.image. It's running the image I've got there. You'll notice lack of version, lack of tag, my bad. But that's the way you run the Docker image, putting my ports in there. And then the loop from line 5, the timeout is basically just saying, wait, give it 30 seconds. If like this wait until in the middle kind of loop, if this does not pass within 30 seconds, fail the build. And you'll see the wait until in the middle is literally just curling the what we've spun up further on. So it's curling localhost 8010/health, and this is a ridiculously simple example of just grepping for the phrase up kind of thing, the word up. That when you hit the health check, it returns a 200 with the text up. And if it finds that within 30 seconds, it returns true and the build succeeds. So this is, again, ridiculously trivialized example, but it's a pattern I've used for testing individual services, individual containers. We can make it a bit more complex now, as if we're going to be sort of testing via the front door. So we want to spin up like shopfront, product catalog, and stock manager. We're doing some kind of end-to-end testing, so maybe some load testing or something. Again, I still like using Jenkins pipelines, but I'll use something like Docker Compose. Docker Compose just allows you to specify the things that need to be spun up together. So this is a bit of an old example, actually, version 2. Excuse me, there's version 3 of Docker Compose syntax now, and has changed a bit with Docker Swarm. This is an old version, you have to excuse that. But essentially, you specify, all the components and how they work together. If you're using Kubernetes, you can do the same thing. You have your kind of definitions of services. You might run something like Minikube locally, and you can, use this file to specify all the things that are run together, how they're going to be running. You deploy them onto something, be it Docker Swarm mode, be it Kubernetes, whatever, and then you kind of run your tests via the front door. A little bit kind of black box like. Again, big fan of Jenkins pipelines, as I mentioned. Typically, I have more stages. I have some notion, you can see here, 3 stages, kind of building, perhaps end-to-end tests, and then the deploying. I'm mainly focusing here on the end-to-end test example. This is another pattern I've used sometimes, where I've got a slightly longer timeout here now because we're running on line 11 Docker Compose up in background mode. So we're using that Docker Compose file that says all these services need to run together. We're spinning that up. You can see the wait until on line 12, and it's basically just kind of polling at an exponential back off. And it just says when the main shopfront returns that it's healthy, then proceed to line 17, 18, and we can run other tests. And again, this test is literally just grepping the HTML that's coming back, grepping for Docker Java, a very trivialized example, but you can put any kind of tests in there you like. At that point of the code, when the application's spun up on a node, on a Jenkins node, you can then test via the front door if you like. The kind of stuff I do in this respect is typically it's testing the NFRs. So it's performance, load testing. Big fan of Gatling. It's a Scala DSL, which you can kind of create performance tests in, load tests. JMeter is awesome, but I think it's a bit old school now. So even as a Java developer, I don't know much Scala, but I know enough Scala to write good, very descriptive DSL for testing. So big fan of Gatling. The cool thing with Gatling is if you can sort of call out to Gatling, as I've just showed in the example. You can take your Gatling scripts and put them into flood.io. And flood.io is a commercial product. I've got no affiliation with it, but I've used it on a couple of projects. Flood.io uses, pay some money, and they spin up a bunch of Amazon EC2 instances, and they hammer your application. So you can say spin up a staging environment, dump your Gatling scripts onto flood.io, simulate your desired level of traffic, and hit your application and watch what happens. So big fan of Gatling. Combination with flood.io, real nice for testing like soak testing, performance testing, load testing as well. In terms of security, I get on my high horse on this one sometimes, but I think we're a bit casual with security as developers sometimes, and particularly that the business is also a bit, blasé about security. I think it's really important. So things like find sec bugs, you can chuck in Maven. It's basically like find bugs, but the security kind of style of it. OWASP dependency check is a kind of like Maven enforcer. It will look for critical vulnerabilities in dependencies in your code base. BDD security is a nice BDD, behavior-driven development wrapper around the OWASP automated penetration testing tool called ZAP. These things are, you can basically codify security principles into your build pipeline. They do not replace human expertise or penetration testers, those kind of things, but they're nice ways to basically check, am I bringing in vulnerabilities into my code base? Have I covered SQL injection? Simple as it may sound, I still see SQL injection stuff in the wild. That's sort of the Java level. You definitely want to, because now we're building a Docker image, we're running a container. You want to think about testing the stuff that's in the container. So things like Docker Bench for security, and CoreSClare. CoreSClare in particular is an open source security scanner for images. So it will look for things like Heartbleed and all that kind of bad stuff at the OS level. So if you're bringing in some old packages into your Docker image, run it through CoreSClare, you can spin it up as a container, and it will fail the build, or you can make it fail the build if you've included, you know, some Heartbleed kind of dependencies by mistake, those kind of things. So codify NFRs in your build pipeline. We'll come on to some of the mechanical sympathy stuff in just a second, but what I'm trying to say here is, when you deploy your Java apps, even if you're like doing a lift and shift and you're putting it in a container, don't assume it's going to perform the same way as it does now. I made that mistake a couple of times. So do put all your load testing in place in the pipeline. Do put your security testing in place, because if it's not codified, it often gets forgotten, or you know, just gets skipped or whatever. This stuff is super critical, I think.
Quick question about Jenkins. McKay's not letting this one lay down. This one needs to be asked. If you use Jenkins, you can't run the same stuff on your local machine. It needs to run in the pipeline, right?
Yep.
So if you wanted to run something on your local laptop, would it not be better to use something like Gradle or Maven, so you can effectively just kick it off on your laptop with the same command?
Oh yeah, so probably my bad, Simon, on that one. So I still use like Jenkins just triggers Maven or Gradle. That makes sense. So I'm a Maven fan. As much as, like, you know, Gradle is super cool, I still like Maven. So I always do, you know, Maven clean verify, that kind of stuff locally. And essentially, like, when we you know, build stuff in Jenkins, we in terms of running, say, the surefire and the failsafe type tests in the Maven world, I do that exactly the same locally as I do in the pipeline. We add extra stuff on top. Once we've Dockerized it, then we add extra stuff on top.
So you can run it locally, or you can just kick it off in Jenkins with literally using the same script under the covers.
Totally, yeah. So I'm a massive pipeline you can do locally and vice versa. And there is often a few extra levels now, like I mentioned. Like, you can use Maven to do a bunch of stuff, but then we typically you saw in the code example with the Jenkins file, you might be doing some extra kind of things. You might be running, say, SPT to run Gatling, for example. But whatever you put in your scripts in your CI pipeline, you can totally run locally, as long as you've got the config set up correctly locally.
Okay, on to mechanical sympathy. I love that phrase.
Yeah, I'm a massive fan. So, like, Martin Thompson first introduced me to this one. He's his blog is actually called Mechanical Sympathy.
Yeah,
if you haven't heard of Martin, yeah, if you haven't heard of Martin Thompson, anyone watching, totally check out his work. Like, again, so I'll caveat this slide by saying there's a bunch of stuff I learned the hard way. I am not a JVM expert. I am not mechanical sympathy expert, I guess. Martin Thompson, like even Richard Warburton, Martijn Verburg, a bunch of people I know in the London space, and there's many sort of internationally, that are much better at this than I am. So I'm going to caveat this. I sort of have bumped into the problems. I think they'll probably know the reasons why they happen and stuff, but I'll just kind of outline some of the obvious problems. Someone even mentioned this actually in the meetup. So in a nutshell, containers are kind of three things. So container technology is fundamentally Linux-based technology. It is namespaces. So you namespace stuff. So one namespace cannot interfere with another. So you namespace processes, you namespace networks, that kind of thing. There's C groups, control groups, which basically set resource limits. This container can only use this much of the CPU. It can only access these things, this much memory, that kind of stuff. And then there's the file system, rootfs, pivot, that kind of thing. So three key things containers fundamentally are namespaces, C groups, and a file system. Now, the namespaces in the file system is kind of like, it's all good. The C group thing is quite challenging for many applications, not just Java, but control groups, C groups, basically enforce at the OS level constraints. Yeah. The only snag is the way a lot of code tries to understand what it's running on, and this includes the JVM, is it uses something like the proc file system, which is like an underlying kind of way to get resource data, or it uses a bunch of other things, which at the moment, some of them aren't C group aware. Yeah, so what I've actually seen, even with Java 8 now, is if you do, there's an MX bean, for example, you can do get available processors, or you can do as a runtime dot available processors. Say if you're running, like example I had, like we're running a 32 core machine in Amazon, so reasonably sized machine, 32 cores. We want each container to run on a single core. So we have 32 containers running, with a gig each or whatever. But the most important thing here is with 32 containers, we might pin each one to a CPU, or we might just say we only want them consuming sort of 1 CPU's worth. The snag is the JVM, when it spins up in a container, will look and it will see all 32 cores, and because it's not C group or task set aware. And the snag with that is things like, you can see on the third line there, the default fork join thread pool size is set on the number of CPUs available, which completely makes sense if you're running on a machine where you've got access to all the hardware. But the snag is if you set the fork join pool to like 32 threads, and then you've only got 1 available, it leads to a lot of performance kind of issues. I presume it's context switching, chopping and changing. Again, I'm not an expert in kind of the why, but I've definitely bumped into, there's 2 issues I've labeled them, put links through to the OpenJDK. The issue has been fixed in Java 9. So when Java 9 rolls out later this year, should be it fixed. And they are planning to backport the work into Java 8 as far as I understand, JDK 8. But just be aware, if you are doing that trick that I've done, and I did it with Mesos, or with my team I should say, we did it with Mesos, we had large boxes because we wanted to have massive network pipes in between the boxes, and we had large boxes because we wanted the containers to communicate very efficiently together. So it logically made sense to have 32 cores, 32 Docker containers running on each box, but we did get burned by this. Performance was a bit funny because the JVM just couldn't figure out how much CPU it had access to. Also got burned, hands up on this one, like my team and I, we got burned on the memory on the second one here. So if you've got a 4 gig heap, logically it might make sense to restrict the Docker container memory to 4 gigs, but unfortunately the JVM, the Java application, will keep getting killed, I found. So you do need to allow a bit extra space. That the JVM itself requires a bunch of memory and metaspace, obviously, or permgen pre-Java 8. And if you're running a thread-intensive application, the threads require native memory. So XSS in this example. So I've sort of, it's a rough rule of thumb, and I haven't found a better way of doing it yet. I've often allowed between 10 and 20% extra over the heap size, just in the kind of these, and this is purely anecdotal. There is unfortunately no real science put this bar experimentation, but I typically allow between 10 and 20% extra. So 4 gig heap would be 400, meg extra or whatever, for these things like metaspace and threads. But even that's not been enough on some really thread-intensive applications. I think it's something I need to look into more to get a bit more scientific on it. But for the moment, that's as good as what I sort of got on some projects. Final thing in this space is entropy. So entropy is kind of randomness. A lot of crypto operations on your machine, so generation of tokens, PKI, all this kind of stuff, requires entropy because it needs to generate randomness. So that things like keyboard input, moving the mouse, network activity, all generate entropy, and they get pooled in this entropy pool, which then crypto operations can then pull the randomness into their kind of algorithms. Now, if you're running like a massive amount of, say, containers and with their own OS kind of thing, and there's not much entropy going into the system because it's a cloud machine with no keyboard, that kind of thing, you can soon exhaust this pool. So a lot of Java stuff under the hood, I've been burnt by this on many different projects. Look at dev random. There's a file system in Linux called /dev random, but dev random is unfortunately blocking. So if the entropy runs out on the host, the application requesting data from dev random will probably block. And I've seen this. Well, I've had applications freeze randomly. I had a drop wizard application freezing. I had a Spring Boot application like failing to boot. And when we actually started debugging it and did a stack trace, we saw both of them blocking on crypto operations. One was like a session generation token. One was, some other kind of crypto. And then we suddenly realized, oh dear, we've run out of entropy. So there's a bunch of things you can do. You can use something like called havget to generate entropy. What a lot of us do is we use dev urandom. So you notice back in the early example where I showed the Dockerfile, I actually put in that I changed the source of randomness to dev urandom, and urandom is kind of pseudo random so that it never blocks. There is always entropy, or there's always randomness created from dev urandom. It's not as random as the actual dev random, so there is some security implications which you might want to look at on that. But I'd recommend if you're stuck on this kind of stuff, have a look at using urandom instead of dev random. Right, so I'm conscious we're pretty close to time. How are we doing for time, Simon? I've got some slides I can skip, or we can kind of wrap up. What do you think?
So we're pretty much bang on time, actually. It's up to you. We could do maybe a couple more slides, or we can take some questions.
Let me just quickly flip. I'll just quickly looking through here. I'll just a couple more if that's okay, and then yeah, I'm off for some questions if
Sure.
that's all right. So I think one of the key things that I do get asked a lot is how should we move to containers? And a lot of people sort of say, you know, we're going to go all in, yeah, we're going to Dockerize everything, we're going to microservice all, we're going to rub some DevOps on it, we're all good, you know. And it's a nice vision, but you know, these kind of the ship here all looks great. But I'm a massive fan of like MVP kind of stuff, minimum viable product, yeah, trying stuff out. And for me, it's often a case of just go simple, yeah. Peel off a little chunk of the application, chuck it in a container, build a pipeline for it, get it into production, and just learn. Yeah, as in, we've done this on a few projects. We've just taken, say, a registration page, or we've done a very simple bit of the application, built it out as a Spring Boot app, as a you know, micro profile app or whatever, put it in a container, built the pipeline, and deployed it. So I'd strongly recommend people do that rather than trying to go all in. One of the, I won't go through this slide in full, but you know, one question I get asked a lot is, should I containerize an existing application like a monolith? And there's arguments on the slides here, and I'll make the deck available. But yes and no. I think you homogenize the build pipeline if you do containerize existing apps, but it can be really tricky. I've had like massive Docker files to kind of get apps working, old school apps, because they're not kind of container aware apps. So these are questions definitely worth asking. If you're building platforms, if you're building stuff to deploy Docker you know, containers onto, whatever you do, make sure that's associated with the pipeline. And this book is a great resource to understand how to build infrastructure pipelines. And it won't make you an expert, but it will definitely point you in all the right things you should be thinking about. Don't forget, it's not just the code pipeline. There probably should be, well, there should be an infrastructure pipeline as well. This is just a final thing I'll recommend. If you are you know, looking to break up an application, go microservice or whatever, do an architectural review first. Make sure you understand what is in the existing application. If you're going to containerize stuff, things start and stop a lot more often. Look for things like file system access in a container world. Often that file system is ephemeral. So you can be writing stuff to disk and the application thinks it's good. And then, of course, the container gets shut down and spun up somewhere else, and suddenly it's lost all its data. So just watch those kind of things as well. A couple of things, you know, hands up on there, I've been burnt. I think that that for me pretty much nicely summarizes, like, you know, nicely sort of wraps up. Hopefully everyone thinks the same. These are the kind of, you know, summary points we've talked about today. I'll let you sort of read them in your own time, but definitely continuous delivery is really valuable. Think about the single binary thing. Understand kind of, you know, metadata, mechanical sympathy, and make sure you apply all the good CD practices that you've been doing for many years. But you know, make them container aware. That's the thing I'd say.
Awesome.
Bunch of book references. I always love doing my book references there, and that is pretty much it.
Awesome. If you could make those slides, I assume they're available already. Actually, if you could send me the URL, or if not, upload and send me the URL.
Yeah, I tweaked them today, Simon. So I'll send you a new one. I'll upload it this evening as soon as I've got.
Okay, thank you. And we'll send that round. In fact, if you was to tweet it, Daniel, then
yeah.
anyone here can follow you and grab that link. A couple of questions. Lots of people saying great lecture and this was great. What's your take? McKay says, what's your take on mocking versus using the real stuff using Docker, like MySQL console and so forth?
Oh, and that's, yeah, another, you know, good question. So I'm slightly biased on this because I've been doing a heck of a lot on service virtualization of late. The Specto, the company I mentioned, we are specializing in that, and we've got our Hoverfly open source tool. So I totally recommend checking out, you know, it's a shameless plug, but checking out some of my other presentations. I've got a microservice deadly sins, or 7 more deadly sins of microservices, which goes into more depth around exactly this topic. And I've written a blog post on Specto about these kind of things as well. So it's a good question. My advice is, like, for third-party services, I'm a big fan of using sort of mocks and stubs, but also service virtualization. So recording requests and responses, for example, from PayPal or from eBay, that kind of thing. I like that to develop. When it comes to databases, I try and make the tests so that I don't need to have databases, because they kind of are often the easy answer to how should I test this? Oh, if I just spin up a database, I can pull whatever I like out of it. So I try and use service virtualization and mocking to avoid spinning up databases. But then when you come to some point in your pipeline, you pretty much do want to test with a real database, even if it's like an in-memory one or whatever. The challenge I found with containers is putting the data in them. I've run MySQL, or again, my team, I should say, we've run MySQL containers, run MySQL in containers. You can kind of pre-can data, which is quite cool. So the images often get quite large, particularly if you're using sort of semi-production like data. But we've done that. We've had like MySQL or Postgres in a container. We spun it up as part of the build pipeline using Docker Compose. So that's totally viable as well. It's not an easy question. My advice often on this stuff is think about what you're trying to prove in terms of, are we going end to end here, or are we just going kind of local verification? That definitely influences your decision. And then how easy is it going to be to spin up these things and curate and maintain the data? This is almost separate to the whole container thing. It's often been quite a challenge I found in my experience of keeping production sort of synthetic data or whatever up to date with what's actually in production.
Okay, and I think you actually did that session, certainly the more deadly sins of microservices, I think you did for VJug 24.
Oh, well, I remember, Simon. Yeah, so that one's already online, isn't it? So you can probably go to YouTube and grab it.
Yeah, VJug24.com, and you'll be able to find Daniel's session among 23 others. We have another, and shout out to John Yeary, who's oh no, he's quit. He's just said thank you for a very nice presentation, then he quit.
Nice.
Roman says, why do we need to use DockerHub or a private hub and not just save the image and use it where we want to build?
So, I mean, the same reason you'd use DockerHub, and I'm not just recommending DockerHub because there's a bunch of other things, but it's the same reason you use something like Artifactory or Nexus. Yeah, you want a common repository which all of your team can access, that is the single source of truth. Yeah, so you do your Maven clean verify, clean install or whatever, where you create or build, then like typically in the Java workflow, you push the resulting artifact, or more correctly, you build it in the pipeline and have the pipeline push it to a central repository where everyone can pull down from. And in this case, the private repo is now the single source of truth, or Docker Hub or Chorus Key is the single source of truth. It's directly analogous to Sonatype Nexus or JFrog Artifactory or other repositories do exist. But yeah, the container registries are directly analogous to artifact repositories.
Okay, awesome. So we're a little bit over time now, but that's cool. So we'll wrap it up there, Daniel. Thank you very, very much for your session. Another great session as always.
No worries. Great.
And also, if you wanted to watch a replay of this session, feel free to either just restart this the video that you're watching right now. It's actually at the same URL, or you can do it via YouTube directly. If you have any further questions offline, feel free to reach out to Daniel at DanielBright UK on Twitter. Cool. He's a very friendly guy and always happy to take questions on Twitter. Unless you catch him on a Monday morning and
without coffee, yeah.
Very, very angry sometimes.
Yeah.
I've seen him like kick puppies in the morning on the way to work.
Definitely not.
It's very bad. Of course I'm doing. Absolutely, Jen. Thank you very, very much, Daniel.
Thanks, Simon. Thanks, Alex.
And we've got a bunch more sessions coming up, including one on Java 9, which is going to be like a 6-hour hackathon on the 22nd of April. So do check that out. And also thank you to everyone in RSC. It's been nice and busy and active in there. And thank you very much for the questions. Particularly shout outs to McKay and CD Thompson1. Not sure if that's Mr. Thompson himself. And among others. So thank you very, very much for everyone's participation, and see you next time on the video.
Thanks, everyone. Cheers.
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 Bye.